podcast.
Yo, we should actually
Make a podcast.
All right. So here we are. Partial fractions. This is still section 7.3. There's actually quite a bit in section 7.3 because all the systems of equations. Plus partial fractions, which this is a new idea. You don't know how to do this. So I'm actually kind of excited for this because, learning something new. For today, you probably won't see why it's in this section, but then like tomorrow, you'll see why we have to use systems to solve partial fractions, and which is why it's in this section. So, first of all, to introduce this, adding these. How would you add these fractions? Yes.
get the same denominator.
Yeah, same denominator. So I would multiply this by x plus 2 over x plus 2, this by x minus 3 over x minus 3. I'll write that in. We don't have to do this. I do this. Why x plus 2? Because that's this. I would FOIL or distribute that, and then add the top. This is this times this. So what do we see here? We know how to take two fractions and combine them to this.
Can we factor that?
Yeah, if you factor the bottom, it would be this.
Just beat that.
X minus 2 times x plus 2. So I'm going to say, we can go from here to here. Partial fractions is going from here to here.
Also just backwards.
Yeah.
Wow. So subtraction.
Many times we've reduced fractions such as this because with one thing down here, we can say it divides each thing up top.
Yes.
So we can reduce it as to x plus 3. Think about that. That might be a solution from the quadratic formula. And you know that you can reduce that. What would that be reduced?
1 plus or minus.
1 plus or minus 2i square root of 3.
Yeah. Yeah, so again, you distribute this to both things up top. Okay, so we can do that. All these are possible because one term in the denominator divides everything in the numerator. But how many times have you made this mistake? Look at that. Split it apart like that. Yes, don't lie. And then you said it equals x plus 4. Okay.
It's not wrong.
It is wrong, actually. It is so neat and nice and tempting, but it's so wrong. Okay, right? Because you cannot split apart the bottom like that. But you can't pull fractions apart like that until now. So when there's like this on the bottom, we haven't been able to split our fraction. But now we will be able to with partial fractions. It's not this, okay, it's something else, but we will learn how to do that. Alright, so remember the fraction we added at the start. How can we go backwards, find the two fractions that add to it? How do we pull apart our fraction? So the question is, given that rational function, what two fractions add to create it? This is called looking for the partial fractions that add up to the whole fraction, which together form the partial fraction decomposition. Okay, so the partial fraction decomposition of this is this. This is one partial fraction, that's the other partial fraction. Together, they form the decomposition. Okay, so words that go along with this topic. Copy that down. Okay, so, you got that? That's just some terminology. Now, as I said, this slide has a lot of info. Over here, I'm going to have little blurbs. This is probably the more useful information to write down. Because these are like the steps to do a partial fraction decomposition. First of all, you have to check, is the degree of the numerator less than the denominator? So looking at degree. In fact, what was that fraction we had? It was x plus
2 over x plus 7.
X plus 7? Okay. So if that's what we're trying to decompose, split apart, degree of numerator must be less than denominator. What is the degree of this?
1.
Degree of this?
2.
2. So it's okay. If this is bigger than this,
So
we have
if
to
they
do
were cubed.
polynomial long division. If that was x cubed plus 7, I would have to divide this by this, because that would give me, the answer to that would be something like x squared plus 2 plus remainder, I don't know, x minus 7 over x plus 2. Actually, might be that.
Wow.
You would then perform partial fraction on this thing, okay? So we will do an example like that in a while. But that is if the degree on the top is bigger than the bottom, you're gonna do polynomial long division before doing partial fractions. Okay, but for this one, we're good. So next thing you do is you factor the denominator. That's step 1. Now step 2, I factor the denominator. And that's just fanciness for saying, yeah, just make sure it's factored completely. Factor as much as you can. Because when I split this apart, these things are going to be what the bottom of the new fractions are. And then, kind of some rules with partial fractions. If your factor is linear, then it splits into, actually I'm going to put it right here, step 3, equals. There's just going to be one number above it. Put in A because I don't know what it is.
What do you mean if it's linear?
Okay, linear, fancy word for saying a degree of 1. Fancy word for saying the highest exponent is a 1. X minus 3. That's compared with, if this was x squared minus 3, we call that quadratic.
Okay.
Or if it was x squared plus x plus 2, also quadratic. So like, if the highest degree is 2. That's going to have a different form that we will see in a second.
For linear equations only had x with 1, and then quadratic equations had x.
Yes, and then it's going to be just an a on top, plus I go to my next factor, and I keep doing this for as many linear factors as I have. This one is a new variable then. I'm going to try to figure out that number. If a factor repeats, it is to the first power in the first fraction, second power in the second fraction, and continue until you account for how many times it repeats. So, different example. If I have x plus 2 over x minus 3 to the third power. Let's say something factored like that. Then my partial fraction decomposition, that's the splitting apart, it would be a over x minus 3 plus, well I have another one, b over x minus 3 squared plus c over x minus 3 cubed. So this time when you repeat a factor, like you go up in a power each time that you write it again. Okay, these are just kind of rules that allow this process to work.
Alright.
And then quadratic factors. If, and now writing another type of example, if I have x plus 2 over x squared plus 5x plus 3, so I cannot factor that, so that's like one factor. I can't break it down anymore, but it's quadratic because degree 2. Then when I do my, well actually here, also in the bottom is an x minus 1. Okay, so now I'm trying to split this apart. It's going to be a over x minus 1, because that's over the linear factor, plus bx plus c over the quadratic factor. So every time you have a quadratic factor, it's this variable times x plus another number. That is the form for quadratic. This is our example. I've already done a part of it. So first of all, if we're trying to decompose this, you ask, is the degree of the numerator less than the denominator?
Yes.
Yeah, so we can do it. And then, is it denominator factored?
No.
No,
I don't think so.
refactor it. Okay. Are the factors linear or quadratic?
Linear.
Okay, so then we use just A, like an A on top.
A.
So I write it like this, as I have already done on the board.
Wait, why A and B?
They're just variables. We're gonna solve for that. Because what is A, what is B?
That's what it is.
You gotta figure out those numbers.
What are they? That's a hint.
So basically we have this equation right here, trying to find A and B. Notice what happens if we multiply both sides by the LCD, which is just saying multiply both sides by this. Let's see if I have it written out. Here, I'll put it right here. So if I multiply both sides by x minus 3 times x plus 2, and we did a little bit of solving rational equations like this back in Algebra 2. On this side, it's kind of obvious, that all cancels.
Yes.
On this side, when I take this and distribute here, the x minus 3 cancels, leaving just a times x plus 2.
Yes.
And then, when I take this and multiply it here,
The plus 2 cancels.
plus 2 cancels, leaving x minus 3.
Yes.
Leaving me an equation like this, okay? Leave it in this form. This is what we call the basic equation, and that's the terminology they have for it.
Let's see.
What we saw, we put the original one and the one with A and B, right?
Yeah. So we're trying to solve for A and B, but first we're going to turn our focus on x. Now in our equation here with x, this thing where I say this equals this is true for all values of x. Right? This equals this. That's true for all values of x. But it depends on the specific value of A and B. What that means is I can choose any x value I want and plug it in here to help make things easier to find what A and B are. So more so, I'm going to focus on this equation, choose any value of x that I want that will allow me to solve for A or B easier. So I want to choose a value for x that will eliminate something for me. For example, 3. If I choose x equal to 3, what happens? So I put a 3 in for every x, but what happens right here? 0b, it's gone, which leaves me just one variable to solve for. So I can find what A is. So we do something like, so that's just kind of explaining what I just said. So I'll write our basic equation right here. X plus 7 equals A times x plus 2 plus B times x minus 3. So we go through this a couple times. First of all, I'll say, I usually use the word let. Let x equal 3. I let x equal 3 because that causes one of these to be 0. So then I have 3 plus 7 equals A times 3 plus 2 plus 0b. So that goes away, leaving me 10 equals 5a. So A equals 2. Yeah, Diego?
So every time you do it, you're gonna try to make x equal one of the numbers so that one of them gets canceled.
Yes. Yeah, because now I don't know what b is, but I'm going to go back to my equation, and this time I'm going to say, what if x is?
Negative 2.
Negative 2, because that causes this to be 0. So I have negative 2 plus 7 equals A times 0 plus B times negative 2 minus 3, giving me 5. Thank you. This would be -5. So divide by -5, divide by -5. Use -1. So I found my two values, meaning I can write my partial fraction decomposition. Presto.
What does presto usually mean?
Nice.
In Italian?
Good film.
So that's not what you call food.
That's pesto.
No, pesto's French.
Whoa, we're doing on the show.
Isn't that when you give someone something presto?
No, it's
Presto
not
Italian.
Italian.
Yo te presto mi comida.
Borrow.
Lend.
So, alright guys, so I found A and B, so that's the final step.
Plug it into that.
Is plugging it into here for A and B. So therefore writing your equation like that.
Oh, hey!
Yo!
Hey.
The flex!
Hey.
Yo, hey, you
Hey,
flex.
sa mahan negra.
Yo, he
Scene
flexing.
1. Wait, isn't B supposed to be? That's black magic.
Hey, qué lío.
That's
Yo,
racist. Okay. So the final, that's the partial fraction. That is it split apart.
So is that what the answer would be? All just.
What is in the purple box?
Yes.
Is the answer.
Okay.
That's the answer.
That's crazy.
Yeah, imagine it hasn't been recording the whole time. So now you gotta make like a new video. By yourself.
We gotta act as
Yourself. He just comes back after the day. Just himself in the room.
We got back to a practice.
And
Very
just
practice.
like
Very
sits in every
practice.
chair that I'm gonna use one of the students and then cuts it together.
We should all have GoPros to see our perspective.
That would be actually sick. No, imagine like everybody had like a live stream of the GoPro. So like from the
Me
first
sitting behind the
scene,
top.
for real, like,
Let's
like
see
for
it.
example, like
Let's see it.
She would
Okay, buddy.
what was it later?
Alright, we got it?
Let's see it.
Let's try
I'm
that
sitting
one
behind
again.
you. It's just nothing.
Partial fraction decomposition. So we ask ourselves.
Is it less than the
Yes.
one?
Yo, what the heck?
What do we
ask?
ask?
Is
We
it-
don't ask ourselves that.
Is
We
the
say-
factor or is the degree less
Yeah.
than
The numerator's degree is less than the denominator.
Yeah. Yep. And so is that true?
Yeah,
Yes.
that's
Yeah.
true.
Okay, so we continue. The next step for you.
Is it factor?
Is it?
No,
Is
factor.
It is not. So how do we factor
Is
it?
it a factor?
1 and 2.
X minus 2, X plus 1. Alright, now it's factored. So,
It's linear.
the factors are both linear. So it splits into A over X minus 2 plus B over X plus 1.
Equals. Yeah.
And I can write
Equals 3.
the original one over here.
Oh, right.
So this is going to equal that. What is A and B? We multiply both sides by this, causing just that to be over there. Okay, come on. Over here, it's going to be A
Over x plus 1. Or times x plus 1.
yep, times X plus 1 plus B,
Times x minus 2.
and that's what we call our basic equation. Yeah. And then we try and now find A and B. So we first choose something to eliminate either one.
2.
Okay, so let X equal 2. So then nothing over here, just 3 equals A times 2 plus 1 plus B times 0. So that is gone. 3 equals A times 3. Divide by 3. A equals 1.
Yeah.
Now B,
Can we do
or to go the other way, I now let X equal
-3?
-1. That will make that be 0. So now it's 3 equals 0 A plus B times -1 minus 2.
Negative
3 equals negative 3b.
So B equals negative.
B equals -1. Now for our final answer, we take that and put together.
One,
put it there.
1 over x minus 2.
Plus -1 over x plus 1.
Can't that be also x minus 2 to the negative? Yeah, I do know.
What it can be is this. I can take that negative and just say minus that. That's actually nicer. That's a nicer way to put it.
To the negative first one.
Hold on, what? Don't we already
No,
have
this has nothing to do with
No,
like
because
exponents of negative.
you see the
Can we
negative
do-
1.
What
Did
do
you
you
even hear what I
But it's
said?
1 over x minus
So you want it to be x minus 2 to the -1?
2. Can it?
It can be, yeah.
Wait till do that. Cut it. Yeah, cut it. Left side of that. This side. Left side.
We're gonna talk about this in a video.
Who?
It's going back. It's really.
Questions? Questions?
I have one. You say hi.
What? Why you listening? Why you listening?
Roberto, trying to be cool in front of the camera, bro. Like, stop.
Who's watching? No one's Crunch.
Who's watching? Oh, wait, you lefty? You're lefty?
I just realized. What's wrong with that?
I'm asking.
What's wrong with that?
There's nothing wrong.
I'm a lefty.
See,
I'm a lefty. So that was the monthly realization from some student that I'm a lefty.
Joe!
Oh my God. What?
Go down.
All these years.
Oh, yeah. Oh, yeah.
Oh my
Yes, sir. When you send the emails, it's gonna be to us directly, right?
What are you gonna put it on YouTube and then
Oh,
Whoa!
YouTube it, but I'll probably leave it unlisted and then just send you guys the links.
I don't know what unlisted means, but like it better mean that nobody can watch
only
it.
us can
Oh
see.
man, you
Only we can see it.
Only someone with the link can see it.
Okay, we're gonna try and fit this one as our last one. We'll just do it all together.
No, you erased the only
We can't.
that I still
We can't.
needed.
Sorry, I went backwards with it.
Oh my God.
Alright, so, first question, is the degree at the top less than the bottom?
No.
What do we do?
Nothing.
It's no solution.
Nope. What do we
Infinite
do?
solution.
Paramedic.
Oh,
paramedic.
We do
Paramedic.
long division.
Paramedic.
Paramedic. Long division.
Did you say paramedic?
What was the other thing we did with the A?
Parametric. No.
Oh.
It does not say no solution. So, we take this and divide it by this. Alright, so it's kind of a long division. X to the fourth plus 2x cubed plus 6x squared plus 20x plus x.
That's whack.
Alright.
X.
What times x cubed equals x to the fourth?
X.
X.
Now we multiply, so we go x to the fourth plus 2x cubed plus x squared. Now we subtract. 0, 0, 5x squared. Drop down, plus 20x, plus 6. What times x cubed equals 5x squared?
Maybe.
You can.
Nothing, because this degree is already above this.
So we divide that by that.
Factor that.
So we're done. Like, what is the answer to this?
X.
X
equals
5x.
Plus remainder.
5x squared plus 20x
Over
plus
plus
6
6
over x cubed plus 2x squared plus x.
Yeah.
Big brain.
And but not that.
So let's pay attention to what this is all saying, like our string of equal signs. We have x to the fourth. Okay, let me just write all this.
But now the numerator is less.
Shut up.
So you can do the.
You really gotta fix that hole in your shirt, bro.
Hey, show it in front of the camera to see
Do
if
not.
it's better.
And remainder.
You want to be.
So we're claiming, well, we know that this equals x plus okay, because this divided equals this. So now, what are we actually performing partial fractions on?
The
X.
remainder.
That's less.
And down the numerator is the
So in our final answer, we're gonna get the partial fractions of this, plus x, and then x plus that. Okay, so now that we can perform partial fractions on that, factoring the bottom,
So we can factor that.
I can factor out an x, like that. Can I factor any further?
No.
Yeah.
Yeah.
This,
Like plus 1.
x plus one,
There you go.
x plus one.
Trying to go.
So, are the factors linear or quadratic?
Linear.
Linear. So it's the form a over x
Oh, I get
A
plus
b over x plus 1.
over x plus one plus c
Over
over
X plus 1 squared.
x plus one squared.
Where did
Okay, now I'm gonna continue on with this, is kind of quickly, I guess. Now, find our basic equation by multiplying everything by this, giving me 5x squared plus 20x plus 6 equals, this is gonna be a times x plus 1 squared, because the x's would cancel out, plus b times x plus 1, because on this one, just one of the x plus 1's cancel, plus c times just x. That is the basic equation.
Not that basic.
Not basic at all. So the first time, I'm gonna let x equal,
-1.
actually well, either way works. I'll start with 0, because that's gonna eliminate these two. So if x is 0, I have 5 times 0 plus 20 times 0 plus 6 equals a times 0 plus 1 squared. Giving me 6 equals 1a, so a equals 6. The next time, I'm gonna let x equal negative 1. Giving me 5 times negative 1 squared is 1, plus 20 times negative 1, plus 6 equals 0a plus 0b minus c, minus 1c. Okay, because the negative 1 eliminates those two. Giving me 5 minus 20, negative 15, plus 6 is negative 9, equals negative 1c, meaning c equals 9. This is a hard one because now a third thing that's new here. Is there another x value I can choose to eliminate something here?
No.
Yeah, I'm sorry that I know I'm going quick with this.
No.
Pause the video later. No, there's not, because there's only like 2 unique x values to pick. But I already know the value of c and a. Like that's not going to
Or you can
change.
plug it in.
Yeah.
So I can plug those into here, choose any x value I want, and then solve for b.
15.
Let's let x equal 1. Okay, that's probably easier. So now it's going to look like 5 times 1 plus 20 times 1. I hope that's still on the camera. Plus 6 equals, okay, a is 6, so it's 6 times 2 squared plus b times 1 times 2, so that's 2, plus c times 1.
9.
Plus 9.
C is 9, so times 9, thank you. And that's 1. Alright, so that's 25 plus 6 is 31, equals 4 times 6, 24, plus 2b, plus 9, giving me 31, equals 31 plus 2b.
24
So
plus
0.
So minus that, 0 equals 2b, so b equals 0. And that can be alright. Let's see what that looks like.
Oh man, that's too much work.
Partial fractions, the final answer. The x plus a over x. So what is my a? 6 over x plus b
0
over x plus
0.
1. I'll come back to that. Plus c
9.
over x plus 1 squared.
TSM.
Final simplified answer.
The one team blue. So you look like a team members. Hasn't been good since double it.
That right there. Okay.
Nice timing, Mr.
Now, I'm not rush through that. As I said, pause the video later.
I got lots of orange.
Yeah, that one involved a lot because that involved the long division because the 3 on top is bigger than the bottom. That involved the idea of a repeated factor. How that, quiet for one more second, where this has to be then squared. And then, kind of because of this repeated idea, we ran out of x values to choose to eliminate letters. So we solved the first two, and then the third one we put in the value of a and c and chose any x value we wanted, 1 because it's easy, and then solved for b.